Another interesting thing that you can try, and I mentioned that we support the legacy particles of Max, which nobody really uses. Probably spray is being used from time to time because it has a blob option, and people that don't have frost might be using it here and there. But one of my favorite examples is that you can go to the particle systems and create the earliest Weber particle system, which is the spray. I'm going to disable the grid so I can see it better. I'll rotate it at 180 degrees about X, so it's emitting up. And what it's doing is it's emitting very few particles over a very short time of 30 frames. This is what it does, 100 particles emitted over 30 frames. That's the life. And these are all the parameters that you have. There is not much that you can actually do with it. Now, if I wanted to emit something that is in similar shape, I could go and say, good, what I'll be creating is a plane with approximately the same size. So it covers the same ground there. I'll keep this plane selected. I also select, in addition, the spray, and I'll create a Stoke object by the side. I don't want to emit from the actual spray particles, only from the plane. I will be emitting the total rate of 100 particles, and I'll hit simulate. And as we know already, particles loaded as a velocity field will be put on a grid, and that grid will be advecting my new particles from Stoke to move together with the original particle from the spray. But when those particles die, the velocity field disappears, so I would have to kill my particles there. I can go again to, let's say, 30 and simulate with similar settings. But right now I'm not deleting, so I'll add my modifiers on top, and now I'm deleting, so my particles die approximately at the time when the other particles are also dying. And of course I can go here, say I want a lot more particles, run the simulation, and on the last frame I will get really a whole bunch of particles that are moving in a very similar manner. As we already know, we have this create fluid motion option, and if I do this and simulate, the result will be slightly different. And it will be moving a little bit left and right because the particles are distributed randomly in space and very sparsely. And the grid that I'm creating, I can go with a smaller grid. Something happened to that preset. So I'll be using a smaller grid, and this will give me a little bit more detail, and you start seeing something that looks more like a flame. I'll switch this one to velocities, and this is what I'm getting. So using the oldest imaginable particle system, which was available in 3ds Max 1.0 back in 96, I can actually create something that looks like a fluid simulation. And this is very similar to what we did with the Ember example in the very beginning and why we actually wrote Stoke. We want to be able to take something mundane as this and create something more exciting looking. Not only that, legacy particle systems in Max, the older ones, have an ability that kind of escapes particle flow. I mean, it's possible to do, but it's kind of tricky. And if I want to create, for example, a spline and let these particles follow that spline, it's pretty easy using the legacy particle systems. You create a path follow, you pick that path, so that will be the space swap we'll be using. We'll bind these particles to this space swap. We'll take the space swap to use offset splines instead of doing parallel. And now these particles, the original ones, are moving along this path. All I have to do is go to my Stoke, resimulate, and my particles will be doing the same kind of fluid motion, but this time following the path. And getting this to work in particle flow is usually tricky because there you're not controlling explicit positions and velocities. You're accelerating particles with forces, so you're actually following a general direction. You can kind of do it by deforming a particle load using Kriktor, and there are tutorials about this on our website. But Stoke in this case is actually performing a simulation. So in this case, I can go, for example, and add yet another, for example, a turbulent wind in addition, and say, okay, this turbulent wind will have very few influence as a strength, but it will have lots of turbulence, 0.05 as before, and to just pick it, I could add it to the particles that are following the spline, but no, actually what I'm going to do is add another wind, another force to the whole simulation, which will be using its own settings. and it will blow the particles additionally. Let's see what the final result will be. Ignore, this is actually just a interpolation of earlier particles on this frame before the simulation is done. And now I'm kind of following the path and adding a lot of turbulence on top. So some particles are diverging from the path, and then they lose the influence from the path, and the rest is still following. So it's a matter of controlling how much influence I'm going to apply from this wind in order to get a different result. I'll stop this one and I'll click the preview option and I'll resume. I can continue my simulation, make changes. Some parameters cannot be changed. That means if I change a parameter, that would change the results of the simulation. The resume button will be disabled, but if I have the same setting and just tweaking some counts and so on, I can actually hit resume. And at this point, I have less turbulence influence from that wind that I added and still following the spline and so on. It's a neat use of a very old particle system to create completely new things. Okay. Obviously, we can do exactly the same with particle flow. In fact, I'm going to skip in order not to run out of time, because we scheduled today's presentation to be actually an hour, but I think I'll go over an hour anyway. I'm going to skip the particle flow example for now, because it's really no big difference compared to what you would do with all the other particle sources, including Stoke and legacy systems. You create the particles, you can make them collide with objects and do everything that particle flow can do alone, and then pick that particle system as a velocity source inside of Stoke and that vector particles and create many millions that follow that general motion.